In this demonstration, we will replicate an on-premise database to Snowflake. I've logged into Qlik Replicate, which was formerly known as Untitled Replicate. Let's start by creating a new task. On the left, you can see that I have prepared my source and target endpoints. This is simply a matter of adding the connection details and credentials for MySQL and Snowflake in this case. Qlik Replicate is an agentless solution, and we do not need to install anything on the source or target systems. So I'm going to drag in my endpoints, and now I can select the schema that I want to replicate to Snowflake. In this case, we're going to use all the tables from our sales transactions database. With Qlik Replicate, we generally use ELT methodology, so we won't be doing any major transformations at this point. For now, we simply want to move our data to a landing area in Snowflake. So I'm going to set up a rule to create the sales OLTP schema in Snowflake. Let's just switch to Snowflake for a minute. We can see that this schema does not exist in the Qlik Replicate database at the moment. We'll come back and take a look at this again later. Now once I hit run, Qlik Replicate begins the job of creating and populating our selected tables in Snowflake. Once the full run is complete, we automatically switch to change data capture mode, where any changes in the data or the structure of the source tables will be propagated to Snowflake. Now I'm going to simulate some changes happening in the source system by running a query in my sales database. This query will insert, delete, and modify certain records. Let's switch back to Qlik Replicate. You can see the changes have been detected in real time and are now being pushed to Snowflake. Let's just run this query in Snowflake to see that our new record has landed. And we can see the new record that I have just created in the source system. So in a few minutes, we have set up an automated streaming data pipeline from our on-premise system to Snowflake. Qlik Replicate supports many types of source systems, from databases and warehouses to mainframes, and gives you a simple and automated solution for moving data into Snowflake. I'm now going to give you a quick introduction to Qlik Compose for data warehouses. In the interest of time, I've already built a project on top of the sales database we replicated in our first demonstration. A data warehousing project in Compose involves several high-level steps, which I will step through now. First, you can see that we have set up a project to build an enterprise data warehouse in Snowflake. A project can connect to one or more source systems. In this case, we're using the sales database that we just landed into Snowflake using Qlik Replicate. In the modeling step, we can use Qlik Compose to detect entities and relationships automatically, or we can import this information manually. Here, we can see the source entities and relationships that were detected by Qlik Compose. We can also generate date and time entities, which are usually essential for analyzing transactional data. One common source of complexity in data warehousing is type 2 slowly changing dimensions. With Qlik Compose, we can easily apply data vault methodology using satellite and hub tables. For each of our tables, we can identify attributes where we need to store history and mark them as type 2 dimensions. This will automatically allocate them to a satellite table. We can also group multiple attributes to be managed in the same satellite table. For example, for the customer table here, I could store history for contacts in one satellite table and the addresses in another one. If you look at the physical model, we can see that this creates a hub table for type 1 dimensions and two satellite tables for contacts and addresses respectively. At the end of this modeling, Qlik Compose generates the DDL scripts for Snowflake without having to write any manual code. Here you can see the automatically generated scripts for our data warehouse using the Snowflake SQL syntax. These scripts can be executed through Compose to physically create the data warehouse, or just generate it and then customize to fit your needs. Switching to Snowflake, we can see that these scripts have been run and our data warehouse tables have been created in Snowflake under our EDW schema. Next, we set up the instruction sets for loading data into our Snowflake data warehouse. You can see that we have created mappings for each of our target tables. Qlik Compose generates the default mappings, which we can then enhance based on the requirements. For example, you can see in the mappings for order details, I have set up two new fields. Line item amount is calculated using other fields in this table, while expected units in stock is a lookup from the product table, which is also in our model. We can also set up data quality and validation rules. In this case, I have a rule that will flag records that exceed a certain discount threshold. These rules will set up our error mart logic. Once the mappings are set up, we can generate the instruction sets. I've already performed this task and can show you the ETL generated by Qlik Compose. Our data warehouse requires 576 instructions, each of which is a direct saving of time and effort in setting up this data warehouse. For example, you can see the SQL behind this one instruction for populating our error mart. This statement applies the data quality check on discounts that I was showing you earlier. Up to this point, I was showing you a project that I prepared beforehand, but now I'll create a new data mart on top of a warehouse in front of you. Qlik Compose supports transactional, aggregated, and state-oriented data marts. In this case, we'll create a transactional data mart for our sales data. We start by selecting the fact table for our star schema. Next, we select dimension tables. I remove the order tables from the model, but retain customers and shippers as my dimensions. For products, you can see that we just have one table in our star schema. The suppliers and categories will be automatically flattened by Qlik Compose into this table. Finally, we select order date as the transaction date. This will be the key date used for type 2 slowly changing dimensions. At this point, our star schema has been defined in Compose. We can go ahead and define new measures or edit our dimensions. Once we're done, we can directly create this data mart in Snowflake using the Create Tables button here. We then generate the ETL commands. You can see that these instructions are not trivial and would take significant development time if approached the traditional way. Now I can trigger the task to populate this data mart. Just to close the loop, we can see the data mart tables are now available in Snowflake. Finally, let me just point out that between Qlik Replicate and Compose, we have set up an end-to-end data pipeline that streams data from our source system to Snowflake, then automatically updates the data warehouse and populates our analytics-ready data mart. It has never been easier to make a move to a best-in-class modern data warehouse while avoiding the cost and complexities of traditional data warehousing projects. In this demonstration, we will see how Qlik Sense Enterprise can work with Snowflake to accelerate your path to insights. For those of you who are not familiar with Qlik Sense, Our analytics platform is powered by a unique in-memory indexing engine. The Qlik indexing engine provides an associative experience that has clear advantages over the query-based approach of other tools. This works great for most sources and use cases, but with Snowflake, we also want to leverage the power and scalability of the underlying platform. So in the second part of this demonstration, you will see a unique way in which live queries and Qlik's in-memory approach come together. But let's begin by creating a standard Qlik app on top of the data mart that we built with Qlik Compose. All flavors of Qlik Sense can connect to Snowflake. In this case, I'm using the SaaS version of Qlik Sense Enterprise, which is a natural choice where Snowflake is the main data source. I've just created a new app and gone into the Data Manager, where we can connect to our data source. Qlik provides a Snowflake connector out of the box. In this case, I've already set up a data connection to the warehouse created in our previous demonstration. I can select my data mart schema and select the tables I want to include in my data model. I can now define the relationships between these tables. Because of the way Qlik's analytics engine works, we need not care about the direction or cardinality of joins, and so this is a very simple task. There are powerful ETL and scripting capabilities available in Qlik Sense as well, but we will just go ahead and load the data in this case. I can now start creating visualizations, either by choosing a chart type or simply dragging and dropping fields and letting Qlik's cognitive engine help to choose the appropriate visualizations. Here we can see how the visualization adapts to the two measures in one dimension I have dropped on it in order to become a scatter plot. Let's add a couple of filters as well, which we'll use later. I could even have gone straight into analysis mode and used natural language to generate content. For example, I'm interested in looking at a trend of average days taken to ship our product. This visualization has been generated on the fly by the cognitive engine's understanding of a data model. I can now add this new visualization to my sheet. As we start to interact with these visualizations, Qlik's associative engine applies a context across the entire app, and everything works in sync to give insights for the questions being asked. For example, selecting the latest year of data updates the scatter plot, and then selecting our top 3 categories updates the line chart. And of course, in both cases, our filters are being updated as well. The values in white here show me customers associated to my selections. But looking at the gray, I can also tell which of our customers did not buy products in our top 3 categories for this year. This is a very powerful experience for the end user and overcomes many problems associated with query-based analytics tools. Taking a quick look behind the curtains, we see that Qlik is able to do this because this app has built an in-memory data model based on the data extracted from Snowflake. However, Snowflake is different from standard source systems that generally perform poorly when bombarded with queries from analytics tools. In this case, we do want to use the power and elasticity of the platform for our benefit. This can be especially useful when the dataset is too large to practically fit in an in-memory application, or when users need to obtain the latest possible data on demand. To demonstrate this use case, we'll use the New York City Bike dataset, which has almost 90 million rows of data. We'll start off exploring this app using Qlik's standard in-memory experience. I can drill into 2019, select Queens, and then identify which stations had more than 10,000 rides. Or I can even search across the entire dataset to find city bike stations around Central Park and restrict the data to October 2019. To give this great user experience while fitting the data into an app that's less than 70 megabytes in Qlik, we're using some smart aggregation of the data. So while we can get information on total rides, start stations, and monthly information, we have excluded more granular information, such as daily data and trip start and endpoints. For that information, we can use live queries to Snowflake. First, let's go to Snowflake and upsize our environment to handle the heavier analytics workload. This is an extremely powerful feature of Snowflake, allowing us to scale up the environment in seconds. That was it. With a single line of code, I've scaled the Snowflake warehouse to Excel. Now back in Qlik, let's select these 3 stations at the south end of Central Park and go to our next sheet. This sheet is using the dynamic views concept, a feature released in February 2020 that allows us to use live queries within the scope of our selections. Let's jump into Snowflake to monitor the execution of these queries. The first query here gets the bulk of our data. Notice the where clause. This has been dynamically generated by Qlik based on our selections and allows us to use a single query that will power multiple visualizations in our app. The second query gets associated weather data that was loaded into Snowflake as JSON files. Back in Qlik, there is a small overhead on top of these queries. This is because behind the scenes, we are building an in-memory app for this slice of data. The reason for this approach will become clear during the next bit of analysis. Now that these visualizations have been loaded, we are free to explore this slice of data with the same great associative experience that I demonstrated earlier. We can do more advanced analysis now, such as popular rides between stations. On this distribution plot, I noticed that the station on 6th Avenue has had an especially long ride. Let's select this station. On the map, we're seeing all the trips in our slice of data. Let's select that outlier that caught our attention. We can now see that ride was from Central Park 6th Avenue to J Street. The customer was a 42-year-old female, and she rode this distance over 3 days. We even have weather information here. So if I go up and select the start date and remove my selection on the specific ride, I can now see weather information for the whole day. Here in Snowflake, you can see that our analysis in Qlik did not generate any significant new queries. We were using the Qlik indexing engine within the slice of data that we got from just the earlier 2 queries. Imagine the user experience if each chart and every selection was generating a new query, and multiple users were using the app. While Snowflake could handle the workload, that would still be an inferior user experience for data discovery. Another approach in Qlik, which in fact precedes the dynamic views concept I showed earlier, allows for a user to generate an on-demand app once they've selected a slice of data that fits certain constraints. In this case, the analysis we were doing earlier can be done in a standalone application. Qlik's approach is novel and unique in the analytics market. It lets you leverage the power and scalability of Snowflake while retaining the intuitive data discovery experience that our customers value and love.